Hello, beautiful people, and welcome. In today's video, we are going through our Are You Ready packet for Chapter 4. As always, I am human. If I make a mistake, please let me know where the mistake occurs so that way I may learn from it. Let's go ahead and get started with question number 1. In question number 1, it is asking us to simplify. When you are simplifying, the first thing you would need to do is to separate every single thing. Now, when you separate these things, make sure that you are using multiplication and you are keeping the root and index attached. So we have the fifth root of 224 times the fifth root of a to the sixth power. Now, I am going to create off to the side a quick little sheet for us, and that's going to be fifth root. And the easiest way to do that is actually going kind of backwards. So I'm going to be writing 1, 2, 3, 4 here. Hopefully that's enough. I don't know if that's enough, but perhaps. And then in my calculator, I'm going to do 1 caret 5, 2 caret 5, and those are going to be what's inside of your fifth root. 3 caret 5 and 4 caret 5. Now what I'm looking for are numbers that are smaller than 224, but that go into 224. So 243 is too big. Definitely the thousands are too big. So I can't use those, but I'm going to test if 32, yes, 32 can go into this fifth root of 224. So I'm going to separate this out one more time, but now I'm going to use the fifth root of 32 times the fifth root of 7. Now you can simplify here, but I am going to go ahead and continue to simplify with my a. So this fifth root of 224 becomes the fifth root of 32 times the fifth root of 7. Now I'm going to focus on the fifth root of a to the sixth. Now this is a variable a. So there's two different ways you can do this. You can rewrite this as a rational exponent, so a fraction exponent, or you can just expand it and write out how many a's you have. The index tells you a group of 5. So we want a group of 5. So 1, 2, 3, 4, 5. And then we have a leftover. Okay, so how does this look like? We have 3 times the fifth root of 32 times the fifth root of 7 times the fifth root. Okay, well, how many a's did I group? Well, I grouped 5 a's times, well, what's my leftover? My leftover was just 1 a. You can do 1 or you can just do a. I want to go ahead and highlight that for you so you know where everything is coming from. And again, we still have that 3 in the beginning that we are not really touching. So let's actually do the simplifying. 3 times, we know the fifth root of 32 is 2, times the fifth root of 7 does not simplify, times the fifth root of a to the fifth power, this right here, because the exponent and the index are both 5s, we just have a, times the leftover is just 1, that cannot be simplified. Now, everything that is outside of your radical, we say outside of the house, like the 3, the 2, the a, those get grouped together, and everything that share the same index, because we are multiplying, these here are going to go both inside of the house, inside of your fifth root. So we have 6a, fifth root of 7a as your answer. All right, let's try again. For b, again, same thing. We're going to separate things out. This time we have a cube root. So cube root of 448 times the cube root of x to the 7th power times the cube root of y to the 7th power. We're going to create our quick little cheat sheet. This time we're doing cube roots. And again, is that enough? I don't know. I don't know. We're going to double check. So we got 1, 2, 3, 4, 5, 6. And again, what am I doing to create the inside numbers? I'm taking my 1. I'm doing caret 3 because our index is 3 now. 2 caret 3. 3 caret 3. 4 caret 3. 5 caret 3. And 6 caret 3. Now again, is that enough? I don't know. Now I need something that's close to 448 to know when I'm done. So I'm going to try one more, maybe 2 more. Let's do 2 more. We don't want to go over this 448. So we got 343. Oh, too big. So I found my first too big number. So now I'm going to take this 448 and start dividing by the inside number. So 3, 4, 3. That doesn't work. So I'm going to cross it out. Then I have 216. Nope, that doesn't work. I get 125. Nope, that doesn't work. I get 64. Yes. Now, the remainder ones here, I did not check. One never works. We don't, I should say one always works. We don't use one. But I didn't check the 27 and I didn't check the 8. Perhaps they also go into 448, but we want the largest number. So let's go ahead and break this apart. I got the cube root of, what was my number? 64 times the cube root of 7 times, and I'm going to go ahead and expand these. Do I have space? Let's go ahead and shift this over. I'm going to shift this over for space. Let's try this again, and I'll color code this for you so you guys can see. So I'm going to shift it all the way over to the left. We got the cube root of 64 times the cube root of 7. Now I'm going to expand the cube root of x to the 7th power, 1, 2, 3, 4, 5, 6, 7, times cube root of y to the 7th, 1, 2, 3, 4, 5, 6, 7, barely made it. And so let me go ahead and color code this. So the cube root of 448 ended up being the cube root of 64 times the cube root of 7. Next, we have the cube root of x to the 7th power, where I expanded 7 x's. And we got the cube root of y to the 7th power, which again, I wrote those out. The cube root of 64, we can simplify to just 4. The cube root of 7 cannot be simplified. Now here, I am going to create groups of 3 because my index is 3. So I'm going to have a group of 3. I'm going to have another group of 3. And I have my leftover of just 1x. Again, creating groups of 3s because my index of 3. And the same thing happens with the y's. I have a group of 3 y's, a group of 3 y's, and I have a leftover y. So here are my y's. Here are my x's. And here are my numbers. Now let's actually go ahead and simplify. I started this simplifying already with my numbers. So 4 is still 4. Cube root of 7 is still cube root of 7. Now here again, when the index and the exponent match, that's just 1. Index exponent match, the root goes away. We do have 1x cube rooted left over. Index exponent match, that's just 1y. Index exponent match, that's 1y. And then again, leftovers. Now what happens here is everything that's on the outside stays on the outside. Everything on the inside gets grouped together on the inside. So we have a 4 on the outside, an x, a y, a y. Now inside, I have a cube root of 7, cube root of y, and cube root of x. So we're going to multiply everything. So we end up having 4. X times x is x squared. Y times y is y squared. Cube rooted, we have 7x, y. Almost forgot my x. And this is the answer. Okay, moving on. C. Now, in this type of simplifying, looks like I have double C's. It's okay. Looks like for this type of simplifying, we do have division inside of a cube root. So we have cube root. Let's split this up. You have 2 options. You can split it up like this. Or what we can do is we can check if these simplify first. So 40 divided by 625, do second, oops, actually, will that work? No, that will not work. Let's try this again. 40 divided by 625, second PRB. Okay, and so this does simplify on the inside. So you can split this up and then do your division, or what you can do is divide first. So here's my cube root. Make this an extra cube root. 40 divided by 625 ends up being 8 over 125. And then after you have done your division, you can then separate your cube roots to have a cube root in the numerator and a cube root in the denominator. Now I am going to cheat a little bit in your writing this out, and B, you did have a cube root, so I'm just going to take a look here. A cube root of 8 is 2. And a cube root of 125 was 5. So we end up having, simplify your fraction if you need to, 2/5 as our answer. D, we have the square root. So we have 4, I'm just going to rewrite it, times the square root of 16, 5 times the square root of 27. We haven't done square roots yet, so I am going to develop my quick little cheat. And again, square root does not have a symbol, and I don't need too many of them because I have 16 and 27. So I know 5 is 25 and 6 is 36. So 6 is going to be too big. 1, 2, 3, 4, 5. So we get 1, 4. So the way I'm doing this again is I'm doing 1 caret. What's the index? The index here is 2. So then we got 2 caret 2, 3 caret 2, 4 caret 2, 5 caret 2. Now, happy dances here. I am seeing that I have a square root of 16 that we can simplify. So we end up getting 4 times square root of 16 is 4. For the denominator, we do need to do 27. Closest one is 25. That does not work. 16 does not work. 9 does work, so we can separate this 27 as 9 square rooted times the square root of 3. And again, our task, what the instructions were, simplify. So anything like the square root of 9, square root of 16, we can simplify that. Let's go ahead and write this out again. So now I have 4 times 4. I'll just keep writing 4 times 4 just for a little bit. We get 5 times 3 times the square root of 3. So now we have 16 over 15 times the square root of 3. Now, whenever you end up with a radical in your denominator, this is a huge no-no. So what we need to do is we need to now rationalize the denominator by multiplying top and bottom by the square root of 3. So even though we have this 15 attached to 3, we're not touching that 15 because it's attached via multiplication. Now, if it was a binomial, we'd have to use conjugates like in E. But here, because of this multiplication, we only take the square root. So let's go to multiply. We have 16 times the square root of 3. 15 inside with inside, so that means now I have a square root of 3 times 3 is 9, which again, we already did 9 here. We know this is going to be 3. Keep going. We have 16 times the square root of 3 over 15 times 3. This is inside of house. This is outside of the house. So no, you cannot simplify those. So we have 16 square root of 3. 15 times 3 is 45. And because these right here are both outside of the radical, outside of the square root, we need to check if these numbers can simplify. So 16 divided by 45, second PRB. And no, it does not simplify. So we end up having our answer as 16 square root of 3 all over 45. Now, in E, notice that we have a binomial, two things in the denominator. These two things are attached together, and we cannot separate them. We cannot simplify anything here. So what we're going to do is we're going to multiply by the conjugate of the denominator. Conjugate is where you keep everything the same except the middle symbol that we see is a plus. So we're going to make that middle symbol into a minus. So 5 and 5, 5 root 3, 5 root 3. And then in the middle, because I see in the denominator addition, now I'm going to make it into subtraction. Now, the easiest way to do this is separating this out via kind of like a table. And this helps you keep organized of what your numerator versus denominators are, especially when you're multiplying. So for our numerator, we have negative 5 minus 2 root 3 times 5 minus 5 root 3. In our denominator, we have 5 plus 5 root 3 and 5 minus 5 root 3. In reality, the numerator is typically the more complicated one because we don't have conjugates in the numerator. In the denominator, we do have conjugates. Reminder, conjugates are where everything's the same except this middle symbol. One's a plus, one's a minus, everything else is the same. Here, everything's different, okay? So for our numerator multiplication, we are going to set up a box method. And this is where you have to be careful because you have a binomial times a binomial. Negative 5, negative 2 root 3. Do not break this one apart. 5 minus 5 root 3. And again, do not break this apart. This is one thing. Multiplying, we have negative times a positive, which is a negative, 25. Outside of the house, outside of the house. So 5 times negative 2 is negative 10. Root 3 is the only thing inside of the radical. Negative times a negative is a positive. 5 times 5 is 25. Root 3. And here we have negative times a negative, which is a positive. 2 times 5 is 10. Now be careful here because now we have an inside with an inside. We have 3 times 3, which is 9. Yes, you have to simplify, which ends up getting 10 times 3, which ends up giving us 30. Now this 30 and this negative 25 need to be grouped together. So be careful here. So let's go ahead and write out what we have. We have, take a look at here. We also have like terms. So we have, let's write this out first. Negative 25 plus 25 root 3 minus 10 root 3 plus 30. Now, like we mentioned before, this negative 25 is positive 30. That's just adding. And then we have two like terms. These are adding things. Be careful. You are not touching the insides. You are just counting how many things you have. So it's the same thing as saying negative 25 plus 30. So we get 5 here. And then here we have 25 minus 10, which is positive 15 of what? Of root 3. So if we have a root 3, we have a root 3, we are going to have a root 3. Put this in a thinking bubble. This is now your numerator. Okay. And then for your denominator, we do have a pattern. This is your difference of squares. So we got a squared minus b squared. So a is 5. And b is this 5 root 3. Now to expand the 5 squared, we can either use a calculator or our brain, which is just 25. Now here on the other side, we do need to expand this as 5 root 3 times 5 root 3. So 2 bubbles, 2 parentheses here. And then when we multiply, we have to do outside with outside, inside with inside. So 5 times 5. And then inside, we have 3 times 3. We still have this 25 minus. So we got 25 minus 25 times root 9. 25 minus 25 times, the square root of 9 is 3. 25 times 3 is 75. 25 minus 75 is 50. Ooh, negative 50. Put that in a thinking bubble because we have that as our denominator. That's not our answer. So to actually write our answer, I'm going to go back up here. That's what I have space for. In our numerator, we have 5 plus 15 root 3. In our denominator, we have negative 50. Now, you have to make sure that if things can't simplify, we have to simplify. 2 ways of doing that. You can use factoring or you can split this up. I prefer to split these up. So that way we can deal with our positives versus our negatives. So, okay, so what do we have? 1 divided, sorry, I don't know why I said 1. Maybe I'm doing the division already. 5 divided by negative 50. You can use your brain or your calculator. We get negative 1/10. So this negative goes away and it's kind of being brought up. Here we got 15 over negative 50. So this is now 3. Negative 50 goes away and we get 10. So what does this look like? Negative 1 minus 3 root 3. And again, we're not adding these. This is just a denominator. So we have a denominator of 10. This is our answer. Yes, you have to simplify all the way. The other way you could have done that is by factoring. Factor out of 5 and 15. Factor out of negative 5 out of 50 and then simplify that. All right, moving on. We're still in the simplify category. So all of this is still simplifying. We're going to continue to simplify here. Let me move my markers. All right. What do we see? We see a binomial in the denominator. This one I am going to do just a little bit quicker because we did do one a few moments ago. Step number 1, we are going to take a look and we see a binomial in the denominator. That means I am going to be multiplying by conjugates, top and bottom. When we are multiplying by conjugates, that middle symbol that we see, this negative, is now going to be a positive. In our numerator, it looks like we only have one thing to distribute. So we have 4 and 8, 4 and 3. Now remember, outside of the house stays outside. Inside of the house stays inside. There it is. I was looking for my calculator. 4 times 8 is 32 plus 4 root 3. Now, Here for our denominator, remember there's a pattern for the denominator. And this pattern is only when you are multiplying conjugates. We got our a squared minus b squared. That means a is 8, b is root 3. Be careful here because we do need to write the square root of 3 twice. 64 minus square root of 9, which gives us just 3. 64 minus 3 is 61. Bring that 61 here. And again, we need to check if we can simplify. If we can simplify 32 and 61, 32 divided by 61, that does not simplify. Sorry, you can't see that. So 32 and 61 cannot simplify. 4 divided by 61. And 4 over 61 cannot simplify. So even if I was to break this into multiple fractions, this would not simplify. So therefore, this is my answer. And I'm going to put a box around it, not a thinking bubble. Okay, moving on. This one here is asking us to simplify. You have two options. If you were to type this into a calculator, you would get absolutely no credit. Actually, I don't even know if it's going to work. So what we are looking for is we're looking for you to rewrite this, showing us that you know what an exponent is versus an index in your rational exponent. Rational just means fractions. So we have 64 with an index of 3. Then we have this value squared. You can put the exponent inside on top of 64, but this way ends up being smaller numbers and easier to deal with. So the cube root of 64, going back here to question number B where I have my cube roots. Cube root of 64 is 4. And 4 squared is 16. This is what we want for work. If you end up not showing us any work, that means you would not get any credit. Okay, let's go ahead and move on. 2. Conversions. Write each expression in exponential form. Simplify your answers. So we're looking for exponents. Now it does look like we already have exponents, and that's okay. So we're looking for two things. If there is an exponent already, and we're looking for the index. Now, if the index is not there, you still do, yes, have an index. It's just 2. To rewrite this, if you see multiple things like 3b, you have to put those in parentheses. If you don't, that means your exponent is only going to be on b and not on 3, which is incorrect. Next, your exponent is always going to go on top. Your index is always going to go on the bottom. If things can simplify, we need to simplify it. This one here, because we are talking about a variable, it will not be simplifiable. Okay, now on this one here, notice immediately that you have in your denominator your radical, okay? So we're going to keep it there just for a little bit. And we see an exponent, and we see 5r, so 5r needs to be in a bubble. The exponent is 3. And the index is 4. Now remember, index always goes in the denominator. Now that we have converted this into the denominator, we're going to bring it up from the denominator into the numerator by making the exponent negative. Okay, so negative just tells you directions. To flip the base, so if it's in the denominator, make it into the numerator. If it's the numerator, make it into denominator. Okay, moving on. Rewrite, or I guess write each expression in radical form. Simplify your answers. Okay, so let's go ahead and rewrite this. We have 5x inside of a root. The numerator here is going to be your exponent. So we can do this exponent into two ways. We can do this as a total exponent, here, or you can put inside parentheses of 5x, but usually on the outside is a little bit easier. Then you have to take a look at your index. Your index here is going to be your 3. So this is a cube root. Now it is asking you to simplify your answer. So we have options here. So this is one of the options. Next, we can have an option of a cube root. Inside here, we have 5x squared. This is an option. So let's go ahead and put boxes around our possible answers. Here's an answer. Or here's an answer. Or if we were actually to square this, 5x times 5x, that would give us 525x squared. All three of these are possible answers. Typically, this one is what I see. Okay, let's go ahead and try again. We have 27x to the fourth, that is my insides. Then all of this is going to have a root. The exponent of this is 1. So we can put a 1 here on the inside, or we can put a 1 on the total outside. And then we have our index of 3. Now again, it is asking us to simplify. So that means I have to split this up. Cube root of 27 times the cube root of x to the fourth. Cube root of 27, again, I can go back here to our first page. Cube root of 27 is 3. Here we can expand the cube root of x to the fourth. I can do a group of x's, 3 x's, which then gives me an answer of 3x times the cube root of x. Don't forget to simplify. The reason we did not break this apart is because I cannot take the cube root of 25 here. All right, let's move on. Question number 3, solving. It says solving rational exponential equations. Remember to check for extraneous solutions. All right, step number 1, you want to make sure that your base and your exponent are alone. So you'll notice that there may be things on the inside outside. So there's things here like plus 20, but that is inside of the parentheses. But there's also things like a positive 1 and this negative here that are outside of the parentheses that need to be removed. Always start with addition subtraction. So I'm going to start with subtracting 1. Here we have negative 216. Bring down the negative. If the negative is giving you a hard time, just go ahead and place a negative 1 here. So that means when we multiply or divide by negative 1, your negative will go away. Here's where we have to be careful. And we want to take a look at our exponent. Here's our exponent. And we want to take a look at the index of our exponent here. When we raise both sides, by the reciprocal, yeah, that seems right. For the spelling, we're going to take 2/3 and raise both sides by 2/3 here. Now, don't let that scare you. Typically, this works out with a calculator. Open 216, close it. Caret, this must be in parentheses. And this gives us 36. Now, what happens on the other side is we end up, if we multiply straight across, I'll do this one time. For the next one, I'll show you that it just cancels out. But we got r plus 20 Here we got 6 over 6, which ends up giving us just 1. So what ends up happening here, your exponents go away. I have some space here, so I'm going to go ahead and shift this over. So we get 36 is equal to r plus 20. Subtract 20, subtract 20. R is equal to 36 minus 20, which is 16. Now I am putting this in a thinking bubble because this is maybe our answer. We do need to check. As we are checking, we're checking for two things. We're checking for a balance, and we're making sure if it's a radical, which this is not, but if it's a radical, we can't have a negative inside of a square root. So here, we're just checking for a balance that it does give us a negative 215. So negative r, so we're going to put in our r value, plus 20, raised to the 2, just kidding, 3/2 power, plus 1. We're checking what that value is after we put in 16. You can just type this in all straight into the calculator. So negative open 16 plus 20, close it, caret, open 3/2 plus 1. And it does give us negative 215, which checks out. So we're going to cross out our maybe, and we're going to make sure that our answer is correct. Okay, moving on to the next one. Same situation. We're going to take a look and see what we have. When we have here our base and exponent, notice I don't have anything in front of it and I don't have anything behind it. So when we raise both sides by the reciprocal power, that reciprocal is 2 over 1, which is being squared. So when we do that to the other side, I'm already writing this in parentheses on purpose. So when I say 2 over 1, that means that on my left-hand side, my exponents, they go away, and I'm left with just 5k minus 36. However, on this other side, I do need to expand out my k minus 6 because now I just have it squared. So k minus 6, k minus 6. We have 5k minus 36 on this side. Extend my dotted line. And here we actually need to expand one more time. You can distribute or you can use box method. It's up to you. We get k times k is k squared minus 6k minus 6k plus 36. Now here we can immediately start combining like terms. We are ending up with a quadratic. Oops, 6 plus 6 is 12. And because we have a quadratic, I am going to be removing this 5 from my left-hand side and this 36 from my left-hand side. And our goal is to get 0. That's 2, carry the 1. And now we have a trinomial with a leading coefficient of 1 that we're going to continue to solve by factoring. Two numbers that multiply to 72, but add up to 17. Let's see what we have. I'm going to type in 72. I'm going to start with 2, and I'm going to check if these numbers subtract or add to, let's see where you can see it, there it is, to 17. So that doesn't work. Does that give me 17? No. Does that give me 17? No. Nope. Does that give me 17? No. Nope. Does that give me 17? Yes. So we end up having two factors of negative 9 and 8, also negative. That means when we solve for our values, it's opposite of what we see. So k could be a positive 9. K also could be a positive 8. Now we can have no solutions. We can have one solution. We can have both solutions. These are our maybes. We need to plug in and double check our values. And again, I don't need to see this check on the exam. But what you're doing when you're checking is you're going to open up your values and plug in and make sure that they work out. So for our check, I have 5 times our k value minus 36 raised to the power 1/2. Make sure 1/2 is in parentheses on one side. On the other side, I don't have space, so I'm going to do it in 2 lines. I have k minus 6, and make sure those two are equal. Again, here, we're going to do the same thing for 8. Okay, so we're going to do open 5 times 9 minus 36, close it, caret, open 1/2, close it. So I get 3 for this one. So this one needs to be 3 as well. 9 minus 6 is also 3. So 9, yes, 9 does work. So we're going to give 9 a check mark. And let's do the same thing for 8. And I am going to cheat. I'm going to go up on my calculator. Where I had 9, I'm just going to type in 8. That gives me 2. And 8 minus 6 is also 2. So that also checks out. So both 9 and 8 are our answers. So then I'm just going to cross out our maybe because we actually did check our work. Okay, moving on. We're going to start by graphing radical functions, square root and cube root, without b. We're not doing b here. And we're going to start off by identifying our kind of like our h's and k's. So here inside we have our h, and here on the outside we have our k. Now remember, h is still inside of a function, so it's going to be opposite of what you see. So for our point of inflection, we're going to have a -8, -5. K for keep, h is opposite, you see. After that, you're going to create a t-chart. And you are going to find some pretty values that can work with a cube root, okay? So here's my point of inflection. I'm going to write that inside here. Now, there's different ways of doing this, and I am going to show you one of them here. So I'm going to take the inside. And I'm going to set the insides to a 1. And I'm also going to set the insides to a -1. I'm choosing 1 and choosing -1 because we know that these are good cube roots. We can take a cube root of 1, which is 1, and we can take a cube root of -1, which is also -1. Now, I can use different numbers, but typically we want the smallest numbers. So you're going to solve for your x value. So I'm going to subtract 8. X is then equal to a -7. This -7 I'm going to bring in and write in here. Okay, I'm going to subtract 8. I get x is equal to -9. This -9 I'm going to write in here. Okay. After you do that, then we can proceed to solve. You can either use a calculator or you can do this by hand. So if we use a calculator, -2, oops, that's a 3, -2 times, make sure you see this because this gets confusing. -2 times, you're going to write 3. You're going to do second, and you're going to do this caret button, which tells us 3 is our index. Now, this does require you to open. We're going to type in our x value of -7. Then we have a +8. Then you have to close it. After you close it, you're going to subtract 5. Press enter, and we end up getting an output of -7. Let's try this again. I want to show you again from the beginning. Please practice with me. -2 times 3 is your index. Second, caret, open parentheses. Yes, parentheses are required here. -9 plus 8. Close it. Minus 5 equals, and I get a -3. Now that I have my 3 points, I'm going to go ahead and graph them. So I start with your point of inflection. Don't lose that. And I'm going to guesstimate where -8 is. So we get 1, 2, 3, 4, 5, 6, 7, 8. And then we have 1, 2, 3, 4, 5, -5. So point of inflection is going to be here. You want to label it either P or I. Next, we have -9 and -3. So about here. And then -7 and -7. Now, unlike a cubic, a cube root function is going to be pointing to the left and to the right. So this one's going to the left and then to the right like this. Domain and range for a cube root and a cubic function are always going to be the same, and that is from -infinity to +infinity for both the domain and the range. You will not have any limitations on either the domain or the range. Okay, moving on. Okay, again, no b values here. We're going to start and we're going to do the same thing. I am going to go just a smidge faster. Identify your h's and your k's. Here's your h, here's your k. That means you have a point of inflection. Opposite of what you see, h, so +5, +2. Create your t-chart here. All right, in your point of inflection in the center, you do need a point above it and a point below it. You're going to take your insides, all of your insides and only your insides. This here, you got to be careful because this is a square root, not a cube root. And this kind of changed things just a little bit. So if we go here and we say, do the same thing, take our insides, set it equal to 1, take our insides, set it equal to -1. And we continue to solve. So +5, +5. We get a 4 here. And here we get +5, +5. We get a 6. So take that 6, you're going to write it in here. And this 4, you're going to write it in here. Now, immediately, the one that gives you that -1. This negative, we cannot use. There's a limit, okay? We cannot take a square root of a negative number. So if I have a square root of -1, that actually gives me I. That's imaginary. We can't graph that. So when I plug in 4 into our x value, that will give me an error. So let's go and start with 6. 3 times. Now here we don't need to do any index, so we're just going to do second x squared. We have 6 minus 5, close it, plus 2. And I get 5. Now, if we do the same thing and try to do 4, it's going to give me a domain error. That means this cannot exist. We have our 2 points with our point of inflection, so be careful with that. We have point of inflection of 5 and 2. 1, 2, 3, 4, 5. 1, 2. Again, label that with a P or an I. And our secondary point is 6 and 5. And again, with our roots, cube root, square root, we are going to be pointing to the left or to the right. So this one's going to the right. And we do have a limit on our domain and range. There is going to be a value that's going to be the smallest or the largest, depending if it's pointing to the left or to the right. As we go off to the right, we're going off to positive infinity. And then here, we have the smallest y value. As we go, again, arrows are two-dimensional, as we go up to positive infinity. So for your domain, it is including 5. You always want the smallest first. And we're going off to positive infinity with parentheses. And for our range, the smallest y value was 2. And we're going off to positive infinity. So square roots versus cube roots. Cube roots do not have any limitations. We can have negatives on the inside. Square roots do have limitations, do affect the domain and range, cannot have a negative on the inside. It makes things imaginary. Okay, let's go ahead. Question number 5. Describe the following transformations in the correct order, in the correct order with your B value. Okay, order does matter. The easiest way to go around this is use the arrow system. So step number 1, you are going to factor out your B value. So it's still inside, but we are going to be removing that 4. Now off to the side, this is what actually is happening. When we take our inside of 4x minus 8, I am going to be dividing by 4, both of them. So I end up with x minus 2 here. That's where that x minus 2 is coming from. That's after dividing out our B value. Next, we want to simplify. Okay, so step number 1, factor out your B value. Step number 2, we want to simplify by breaking things apart. Now, this is a square root, so I'm going to take a square root of 4, then keep the square root of x minus 2. We still have that plus 5 in the end. 2 times the square root of 4 is 2. So what we have is 4 times the square root of x minus 2 plus 5. This is what you're going to describe. So, arrow system, we have a vertical stretch by 4. Looking at opposite of what we see on the inside, we have a right 2 for our h value. And for our k value, we have an up 5. Again, so order does matter of what you're doing. Step number 1, factor out your b, keep it inside of your root. Simplify your root by splitting it up using multiplication. Simplify any radicals that you need to simplify, and then describe at the end. Let's go again. This one is a cube root, so be careful here. All right, let's go ahead. I hesitated for a second. That's okay. Step number 1, let's go ahead and factor out that 1/8. So pull out that 1/8. You're going to have something left over. So what ends up happening here, again, we are still dividing by 1/8, but if you're using a calculator, please make sure to put parentheses around your 1/8, otherwise it won't work. So for example, we have 1/8 divided by 1/8, that's just going to give us 1. But if we have 1 divided by 1/8, that gives us 8. Okay, so be careful on that. So I'm just going to write x minus 8 here. We do have this plus 2 still on the outside. After you factor out your b value, yes, you want to continue to simplify. So we're going to pull out that 1/8. Then here you're going to, with multiplication, have your x minus 8, and then we have our plus 2 left over. This goes back to one of the first simplifying questions we had in this packet. So we need to separate this out as cube root of 1, cube root of 8, and we still have the cube root of x minus 8, and then we still have our plus 2. Cube root of 1 is 1, cube root of 8, and there is a trick on the calculator. You can do cube roots, so 3 second caret, and then we can type in 8, which gives us the cube root of 8 as 2. We still have our cube root of x minus 8, and then we have the plus 2. After we have simplified our cube roots, we are going to describe. So we have a vertical compression by 1/2, opposite of what you see. So we're going right 8, and then we're going to go up 2. Now it is also asking us in bold, state the domain and range of each. So for your square root, you're going to take a look at your, excuse me, your endpoint. Your endpoint is your, oh, give me a quick second. I just realized something. In B right here, it's not point of inflection. That's weird. That's your endpoint. Make that correction, please. That's a typo. That's an endpoint. We don't have a point of inflection here. All right, so for square root, we have our endpoint, which is our h comma k. Our h comma k comes from here, not in the beginning, not when you factored here. Well, I mean, technically, after you factored, that can go in. But when you're describing, so opposite of what you see, 2, and then 5. We are pointing to the right. It is an increasing function. So here's your x value. Here's your y value. So for your domain, we're going to take a look at the x value. Smallest, not because 2 and 5, we're just looking at the 2 for domain, and then we're going off to infinity. For your range, we're looking at the y value, which is 5, and we're going off to infinity. Okay, this is your h and your k value. For the cube root, a little bit easier because it's always the same. Cube root does not have any limitations, so for your domain and range, you don't really need to look anywhere. You're just going to always have all real numbers. So your domain is going to be from negative infinity to positive infinity, and your range is going to be from negative infinity to positive infinity. Again, for cube root, it's always going to be the same. For square root, index of 2, you got to look at your endpoint. All right, let's go ahead and solve radical equations. Step number 1, you're going to make sure that you have your radical by itself. Anything attached to it in the front or in the back needs to be removed. Dotted line, you're going to look at the index, and you're going to raise both sides by that index. So if our index is 2, I'm going to square both sides. What ends up happening is the index and the exponent, they undo each other. And then here we have 5 squared, which is 25. I'm going to add 3 to both sides. This is linear. We're back in IM1, solving a 2-step equation. 5, 6, 7, 8, divide by 4, divide by 4, and we get our answer. Now, remember that when we are solving equations, we have to check for extraneous solutions. So this is still a maybe. With a square root, we have to make sure it's not a negative on the inside and that there is a balance. So here's our square root. Here's 4 times our x value minus 3, and that is supposed to equal 5. If it does, great. If it doesn't, then we say it's an extraneous solution. Let's put in 7. Now, when you're typing this into the calculator, do not type in that square root. If you do, sometimes with a negative, it ends up kind of messing you up. So we get square root of 25. Square root of 25 is 5. And so, yes, this answer checks out. We no longer have a maybe. All right, moving on. Next one. For B, notice that we do have two cube roots on both sides. So we're going to select one of them to move over to the other side. So what that looks like is I'm just going to add the entire cube root to both sides. Now it is equal 0 on the other side, which is beneficial, which is helpful. Because now we have a cube root on one side of 2x minus 5 and a positive cube root of 8x plus 1. Now if we take a look at the index, now it doesn't matter which one we look at. The index is 3, so I'm going to be raising both sides by an exponent of 3. Now again, this question started out a little bit icky, but if we take a look at the index and index and exponent, they are the same, which means we remove them and we're left again with 2x minus 5 is equal to 8x plus 1. Back to a linear equation, dotted line. I'm going to subtract 2x, bring down the negative 5, and subtract 1, which gives us x is equal to negative 1. Thinking bubble because this is a maybe. We do need to check our answer to see if that actually is correct. All right, let's go ahead and check. We check by plugging things into, x. You can use parentheses if you want. Again, when you're doing this, don't actually do anything with the cube root. We're just looking at the insides if they're going to give us 0 after taking the cube root. So this is what it looks like. What are we checking? We're checking negative 1. So we're going to put in negative 1 here. So 2 open, negative 1 close, minus 5, cube root of 7. Now there is no cube root of 7, but that's okay. Don't type that into the calculator. Minus, and cube root of 7. So if we have a cube root of 7 minus a cube root of 7, does that give us 0? Yes. So that means we no longer have our maybe, and that negative 1 is, in fact, our answer. Okay, moving on. C. Now for C, I want you to take a note that on one side we do, yes, have the square root on its own. On the other side, we actually have two things. We have the square root of 3x minus 8, and, again, there's a big and here, we have this plus 1. So because we have this plus 1, this is a binomial, so this is a question that was going to take us 2 rounds to solve. Round number 1 begins by you focusing on this right here on the right-hand side, the square root that is by itself. The square root that is by itself, we are going to look at its index, and we're going to square both sides. Now, since our index is 2 and our exponent is 2, we're left with x plus 5. This is a good thing. Now, on the other side, this is where the issues start happening because we have a binomial. So we have to expand by writing this out twice, 3x minus 8 plus 1 times the square root of 3x minus 8 plus 1. So we have two things happening. We have our 3x minus 8 square rooted. And we have our plus 1. Now, you have a choice to make. You can do a pattern, you can do box method, you can do distribution. Okay, I'm going to choose distributive property just for space, but you can do a box method off to the side. No, actually, I do have space. Let's go ahead and do a box method. So do not split any of your roots up. This one thing. Okay, here we have a square root times a square root. That means I have a square root squared, which means my index and my exponent go away, and I'm left with 3x minus 8. But here I have a 3x minus 8 times 1, a 1 times 3x minus 8, and 1 times 1, which is a positive 1. So here on our left-hand side, we are left with 3x minus 8. I'm going to add these together, which gives me a positive 2 square root of 3x minus 8. And then here we have this plus 1. Combining like terms, I have 3x minus 7 plus 2 square root of 3x minus 8. Now on the other side, I do have my x plus 5, x plus 5. Now our goal is to get the 2 positive square root of 3x minus 8 alone. So we are going to be moving things to the other side, like a 3x and a 7. So we're going to subtract 3x and add 7 to remove them. We're going to bring down the 2 positive times the square root of 3x minus 8. Here we're going to do our addition subtraction, so I'm left with negative 2x and 12. Now here, when you are removing this positive 2, we need to remove this by division. Now be careful here, you can't just divide by drawing one line and 1, 2. As a division, we actually have to divide each term. Our 2's go away, we're left with the square root of 3x minus 8. Here we have a negative x plus 6. This is where you're into round 2. Our goal is to remove the square root from our problem and solve for x. But right now we do have the square root of 3x minus 8 still. So we need to undo that by taking the index 2 and squaring both sides. So I'm going to square my left and my right-hand side. So on the left-hand side, this is a good thing. We end up having just 3x minus 8. Our index is 2. Our exponent is 2. That goes away. But on the right-hand side, we're on round 2 and expanding, giving us negative x plus 6 times negative x plus 6 twice because we had an exponent of 2, which means I need to once again distribute FOIL box method. I did box method last time, so I'm just going to distribute. Negative times negative is a positive. X times x is x squared. Negative times positive is a negative 6x, negative 6x, and positive 36. This is a quadratic. We do need to combine like terms, meaning I need to shift everything over to the right-hand side. I'm going to subtract 3x, and I'm going to add 8. And I kind of do this all at one step, and our goal is to get 0. Once we get 0, we are then moving on here to solve by factoring. You can, I repeat, you can use the quadratic formula for this if you are uncomfortable with your factoring. We got 12 minus, 12 minus 3, which is 9. 36 minus, just kidding, plus 8 is 44. So we want two numbers that multiply to, hold on, I made a mistake. This should be a negative, which gives us negative 15. This is wrong. There we go. That's better. Two numbers that multiply to a positive 44 but add up to a negative 15. What are we looking at? We have negative 11 and negative 4, which gives us two possible answers. X could be a positive 11 and X could be a positive 4. Again, this is a maybe situation. We don't know if that's true. We have to check. Now, when you are checking, let's go back to the original equation. And we have two checks. We have to check X is equal to 11, and we have to check X is equal to 4. So bringing my paper all the way up, we have two things. Again, for space, I'm just going to separate them out. First one I have to check is the square root of 3 times x minus 8 plus 1. If that's the same as square root of x plus 5. And I'm checking. The only reason I'm doing it on top of each other like this is because I don't have space. And again, 3 times the square root of, the square root of 3 times x minus 8 plus 1. And then the square root of x plus 5. We're going to plug in those values. And check. Again, do not do the square root unless we can. So this is the square root of 25 plus 1. And this is the square root of 16. So square root of 25 is 5 plus 1. This gives me 6. Square root of 16 is 4. So 6 and 4 are not the same thing. So 11 does not work. Okay, so now we try the second one. Now again, you could have a no solution situation. It could be that both of them fail. We just don't know yet. We got 4, so square root of 4 plus 1. So we get 2 plus 1, which is 3. And we get the square root of 9, which is 3. This one, yes, this one does work out. So again, we no longer have maybe. We know that 4 is a solution and 11 is not a solution. Okay, moving on. Next up, we have inequalities. We have a square root inequality and we have a cube root inequality. You do treat them differently because their indices are different. For a square root, we have an even index, and even indices mean that we can't have a negative inside of a square root, fourth root, etc. We're going to create a little table here, and we're going to separate things out. You're going to take the inside, and it's always going to be greater than or equal to 0. So 4x plus 8, and the symbol, this symbol, no line underneath it. So that means I'm going to set it equal to greater than 0. We're going to solve. So, minus 8, divide by 4, divide by 4. Put that in a thinking bubble. It's not equals to. That is incorrect. We have a greater than. Next, we're going to solve the original. For the original question, we have a square root of 4x plus 8 minus 3 is less than 1. I'm going to add 3 to both sides, get rid of that. Now remember, when you are solving, if you are multiplying or dividing by a negative number, you have to flip the symbol. Now that we're here, we have the square root by itself. We're going to square both sides because we need to get rid of the index and bring out our insides. So 4x plus 8 is now less than 16. We continue solving. So far, we have not multiplied or divided by a negative number. So our symbol, notice how I'm writing down the symbol, it's staying the same. We have 8 here, divide by 4, divide by 4. X is less than 2. Here we're going to graph. You can also test your points here in this section. Graphing will give you your answer if it's an AND statement or if it's a singular inequality. Okay? So our first one we have some number is greater than negative 2. I encourage you to translate this in English. We're going to have an open circle. Some number is greater than negative 2, so our bigger side is to the right and our smaller side is to the left. So if some number is bigger than negative 2, we're going towards the right. Next, we have some number is less than smaller 2. So here's 2. Here's some number, and it's smaller. So we're going that way. And so what you're going to see is an overlapping. Either the arrows are pointing the same direction, and you're going to have a singular inequality as an answer, or your arrows are pointing in different directions. If there is an overlap, that means you have something called an AND statement. So since we have overlap here, that means we have an AND answer, which looks like we're going to take our negative 2 less than x less than 2. This is our answer. This is called an AND statement. And you saw this in Integrated Math 1. Okay, for a cube root. Now, cube root, because the index is odd, you do not have to worry about setting the insides greater than 0. It can be negative. We can take a cube root of negative 1. It's just negative 1. So we don't technically have to worry about that. So we just solve. So we're taking this statement here. And we are continuing. So cube root. Oh, I don't know why I wrote that lower. That was weird. We're taking a look in the index. Index is 3, so I'm going to cube both sides. So that means 2/3 x plus 1 is what I have. 6 caret 3 is 216. And again, we continue. Minus 1, minus 1. 215. Did not multiply or divide by a negative number here. And then here is where I can see some issues happening. Don't worry about this. You have two choices. You can either multiply by the reciprocal or you can divide. It doesn't matter. If you are choosing to divide by 2/3, you can do that. But when you do that, you have to put this 2/3 in parentheses in a calculator. Oops, divide. And you end up with a, that's weird. Hold on. It shouldn't be icky. It should be pretty. So why is it not working? Hold on a minute. Let's see what we have. Make sure I copied it down right. 6 caret 3, that's 216 minus 1, that's 215. That's good. Let's multiply here by, I think, all right. So I was for a moment thinking that it should be a pretty answer. It looks like we are going to have a decimal. Again, decimals are not allowed, so we need a fraction, but that's okay. So if we were to do it the other way, this is fine. Again, we can convert it. I am going to show you the other way just because I hesitated. So I want to show you both ways now. If we were to do this by multiplying by the reciprocal, we would multiply by 3/2 both sides. 2 and 2 go away, 3 and 3 go away. We're just left with x. It's still not multiplying or dividing by a negative number. So that's still fine. We don't flip the sign. We got 215 times 3, which is 6 45 divided by 2. And that's probably where the issue is. This is 5 and that's 2. And so we have a fraction. So second PRB. Yeah, and this doesn't simplify. I'm just checking. We can also do it the other way. 2 divided by 6, 4, 5. And again, that doesn't simplify, so we keep our fraction. I am off to the side going to write out, oops, not that. This is about 332.5. And that's pretty much it. So we are going to draw out our number line to see where our values are. And we're going to translate this just like we did before. So this is some number is smaller than this 322.5 as a fraction. So we're going to find that number again. We're guesstimating where that is. I'm hesitating going between fractions and decimals. No decimals, fractions, fractions, fractions. 645 over 2, open circle, we are going smaller. And so we have our x value as less than 645 over 2. Again, sorry about that hesitation. It threw me off. I expected a pretty number and it's not. All right, moving on. Composition of functions. Composition of functions, we want g of f of n. So the way that you're going to do this, you're going to write this out first. And the second one is going inside of the first function, replacing x. So step number 1, you're going to write out this g of n function. Step number 2, you're going to open up for your n. And then you're going to take your f function and you're going to, in place of n, you're going to write this 2n plus 4. You're going to simplify the following. And so this is just 2n plus 4 minus 3. 2n plus 1 is what you have. And that's it. And so you can write the notation in different ways. You can do g of f of n, or you can say g of f of n like this in your final answer. It doesn't matter if you use this little circle or not. But here is our answer for 8. Okay, moving on. This one is saying f of g of a. So again, you're taking a look at your first letter. So f is what we want, a squared minus 4a. We're opening up a. Then g is our second. We're going to put g inside. So here's your g function. So negative 3a plus 3 is going inside. Negative 3a plus 3 is going inside. Now this one is a little bit more complicated just because you can have a squared, which means this negative 3a plus 3 needs to be written out twice. Take this negative 4 and distribute it. We get positive 12a, negative 12. Here we need to distribute as well. Negative negative gives us a positive. 3 times 3 is 9. A times a is a squared. Negative 3 times negative positive 3 is a negative 9a. 3 times negative is negative 9a. Positive positive is a positive 9. So we have 9a squared minus 18a plus 9. And then I'm going to bring our 12s down, plus 12a minus 12. Combining like terms, we get 9a squared. I get an a. Careful here with your a's and your 9s. We get 18 negative plus 12, which gives me a negative 6a. And we get positive 9, negative 12. and we get a -3. Now again, your notation can be different notation. You can use the same notation, f of g of a here, for your answer. Function notation is required. Moving on. Now, solving for inverses. Step number 1, there is here a limitation on your domain for this given function. Okay, this given function has a limitation. So what we're going to do is first, step number 1, we're going to make this notation, this function notation, into our original x and y. Switch your x and your y, and now you're solving for your new y. So I am going to subtract 3, x minus 3 is equal to y squared. Taking the square root, and let's bring this up. Okay. Now, when we are doing this solving for inverses, we are making sure to have inverse notation. So even though this looks like it's equal to y, it's not. We need to cross that out because y already has a value. It's x squared plus 3. It's not whatever this is. So we are writing this in function notation. We have the square root of x minus 3 is equal to f inverse of x. Okay, now since we are switching our x's and y's, we do need to have the x here that we had switched into a y. And this is going to be a limit on your range because there was a limit on your domain. Now there's a limit on your range. You're still switching x's and y's. Moving on, we have the fifth root here. Be careful, this is still asking for inverse. Take this function notation, make it into a y. We do have a fifth root. Subtract. Just kidding, not yet. We do need to switch our x's and y's. Now, I don't have an x, I have an n. So you have a choice here to make. You can keep your n if you'd like, or you can make it into an x, which is not that big of a deal. Now, I'm going to subtract 8. And then I'm going to raise both sides by the fifth power. Now, the issue here, and yes, I have seen this in the past, I've had some individuals go ahead and try to expand this. Do not expand this. Our goal is not to write this in polynomial form. Our goal is just to find its inverse. So please do not expand this. Not done yet. We need to solve for y. So I'm adding 3. Y is then equal to n minus 8 raised to the fifth power plus 3. And again, you don't have y. Y is something else, so we need to write inverse notation. So the inverse function notation is the inverse of n is equal to n minus 8 raised to the fifth power plus 3. No limitations on domain range, so this one is the answer. Okay, number 10. State if the given functions are inverses, and you must use the composition of functions. So to do this here is you're going to be checking 2 items, and 2 items need to be checked always. And that is your f of g of x and your g of f of x. Both must be equal to x. And if yes, both of them are equal to x, then yes, they are inverses. If one of them does not equal to x, that means no, it is not an inverse. All right, let's go ahead and give it a try. So if I wrote f of g of x first, so that means I'm going to take my f, I'm going to open up for x. I'm going to take my g and put it inside. Distribute that -2, +2, -8. And again, my goal is just to simplify here and make sure it simplifies to an x. -8, 3, and I get -11. Does this simplify to x? No. Does not simplify to x. Now, this no need to check already failed inverses. You don't need to check. If one of them is already not simplifiable to x, it's already giving you your answer. Now, this is not the answer. This is your work. So, state if the given functions are inverses. So, the answer is no, not inverses. And this right here, this is your work. Okay, let's try again for B. Setting up our table here, f of g of x, and then g of f of x. And again, I usually write my f first, so my function is 3, open, n minus 2. So that means I'm opening up for n. Be careful here. And inside, I'm writing in my g. So 1, open, n plus 2, plus big 1. Make this one a little extra. These two can be simplified. So we get 3, open, 1 over n plus 2 minus 1, big 1. This is a trick. You have to combine like terms here by creating common denominators. So I'm going to write this 1 as, careful here, n plus 2 over n plus 2. I'm going to highlight that so that can make sense. So here's my 1. Here's my 1. Common denominators, multiplying top and bottom by n plus 2. So now I have 3 open, I guess not open, over. I'm going to subtract, so I have 1 minus n plus 2, yes, parentheses are needed, over n plus 2. And this is where you're going to do keep, change, flip, KFC method. Here's my division, my original division bar. We're going to keep the numerator. We're going to change this to multiplication, and we're going to flip my fraction. Careful here on how you're multiplying. There is a 1 in the denominator. So we end up having here 3 times n plus 2 all over 1 minus open n plus 2. No, you cannot simplify those n plus 2's. This is saying 3n plus 6 all over 1 minus n minus 2, which again is giving us 3n plus 6 all over negative n minus 1. This right here is not x. It's not n, right? So since we are using n, let's go back here and say not of x, but of n. Our goal is still the same. If we're using n, we need to simplify to just n. If we're using x, we have to simplify to just x. So this right here is not, does not simplify to just n. So what this means is no need to check, already failed inverses. Now, again, all of this is your work. You can't just give me an answer without showing me your work, but you can't show me your work and not give me an answer. So for your answer, you're going to write no, not inverses. Alrighty. The following questions are possible extra credit questions. I am going to pause this video and do the video for the extra credit questions separately. Enjoy the rest of your day. Bye.